Hi, my name is Abubakar Ibrahim. I am a third year PhD student at the Institute of Space Science. I'm working under supervision of Dr. Nandaria. My title for my project is Search for Transients Event and Pulsars in Multi-Frequency Data. Just gonna leave this. So I'm just gonna say a few words about the magnetars. Magnetars are isolated a subgroup of isolated neutron stars with high magnetic field. The decay of their magnetic field, it seems to be the main resource for their electromagnetic radiation. As you can see in the diagram, we call it the period and period derivative diagram, plotting the whole population of pulsars. We will see different classes, and magnetars are located at the top right corner of the diagram, shown in the green stars. And as you can see, they have relatively long spin period and large spin period derivative. Magnetars are found to emit a soft X-ray emission with luminosities of range of 10 to 31 to 36 Earth per second. Magnetars also found to show number of transient activities such as burst, giant flare, and outburst. This outburst event is a sudden increase in their persistent X-ray flux. The work has been done in 2022 to 2023. I have been able to publish an article about the first outburst of the young magnetar SGR J1918 in Astrophysical Journal. So the main idea of this article is to use number of X-ray telescopes, such as X-ray star and also radio telescope to study the spectral and timing evolution of the young magnetars after the occurrence of the outburst. I will just show the main result for the spectral and timing. So for the spectral, as you can see here, we observe a reduction in the observed flux with time. This is starting from the occurrence of the outburst and until 19 months after the outburst. For the the radius of the black body region, we observe a reduction in the radius for the first 7 months, as you can see here, and then it becomes a constant. And also the temperature of the black body region, we observe a constant value for the temperature. Viewers also about the the radio result is we have been able to detect a radio counterpart of the source, which shows here in the at the center of the photo in this cross, and the arrow shows uh, the movement of the source. We also been able to detect a half ring of diffuse radio emission. We suggested that these diffuse emission due to the scattered halo of this young magnetar. I have been able to also deliver an oral presentation during the last the X-ray Universe Symposium, which held last month in Greece. So the current work will be more focusing. I'm also I'm working in a paper, another article, which will be published very soon. Currently, I'm in the discussion, and the aim is to publish it before the summer holiday. This paper mainly focuses on the reactivation of the last reactivation of the Magnetar J1935. It shows a new bursting and outburst event. Here I'm just showing the best fit for the first epoch spectra. We fit the spectra with black body plus 4 low. And here I'm just showing the post-fit residual of our timing solution, which we have been able to obtain a coherent timing solution for this source. Plan for next course. So in next course, we will mainly focus in the search of transient event and the pulsar in the archival data. Here specifically, we are currently waiting for the second data release from Rosetta, which is scheduled in next September. This Rosetta is the extended Roentgen survey with an image telescope array is a wide field X-ray telescope on board the Russian and German observatory. So as you can see here in this figure, this telescope covers large area of the sky in an energy range of 0.03 to 8 kilo electron volt, which will give us an opportunity to find number of sources and transients event. So we will achieve this by developing a search pipeline that will enable us to perform the search for transient and periodic signal in this archival data. We have already established working in this pipeline, and hopefully we will be in due time by the releasing of this data. And thank you.